All right, today we're taking a trip to a place that, at first glance, looks like just another pretty collection of stars, Messier 4. But, looks can be deceiving, because hidden among its ancient suns are some of the weirdest objects you can imagine, and a deep, deep mystery that kind of messes with our understanding of how stars are supposed to live and die. So, let's get into it. So here it is, Messier 4, in all its glory. Think of this as a family photo of over 100,000 stars. It's this incredibly dense city of suns, all held together by gravity. You can find it in the constellation Scorpius, and it just so happens to be the closest one of these globular clusters to us here on Earth. That means we get a front row seat to all its secrets.
You see, being so close makes it the perfect cosmic laboratory. But when astronomers started really looking, they realized this stellar city wasn't quiet at all. It was actually broadcasting these strange signals and hiding this really deep generational secret. So what in the world is going on inside Messier 4?
Okay, so to kick off our investigation, we first need to get a feel for the scene of the crime, so to speak. Let's really get to know M4, our seemingly normal, run-of-the-mill cosmic neighbor. M4 is what scientists call a globular cluster. The easiest way to picture it is like a huge, spherical suburb of the Milky Way. It's just this tightly packed ball of some of the oldest stars in our galaxy, and the whole thing orbits the galactic center as one big unit. And, as far as galactic neighbors go, it's practically right next door. At only about 7,000 light-years away, that makes it the nearest globular cluster we know of. And this is so important. Because it's so close, our telescopes can get a way, way clearer picture of what's happening inside than with any of the clusters that are farther out.
And that super clear view? Well, it turned up something nobody expected. This ancient, supposedly sleepy city of stars was giving off some very weird, very high-energy signals. It was time to launch a full-blown cosmic forensic investigation.
Now, to crack this case, astronomers brought out the big guns. They used the Chandra observatory to listen for powerful X-rays. They tuned into radio signals with a very large array. And then, of course, they used the legendary Hubble Space Telescope to get a super sharp look and see exactly what was what. It's this multi-pronged attack, looking at different kinds of light to make sure nothing gets missed. So, what did all this cosmic detective work actually find? Well, it turns out the signals weren't coming from normal stars at all. They were coming from this whole bizarre collection of cosmic misfits. A whole catalog of exotic objects that were hiding out in the cluster. So first up on our list of suspects, cataclysmic variables. Honestly, the best way to think of these things is vampire stars. You've got this super dense, dead star, a white dwarf, and it's orbiting so close to a normal star that it's actually siphoning gas right off its partner. All that stolen material heats up and starts glowing like crazy in X-rays. Okay, suspect number 2. Active binaries. For this one, picture two normal stars locked in an orbit that is so tight, they're tidally locked. Kind of like how the same side of the moon always faces Earth. This frantic cosmic dance spins them up really fast, which supercharges their magnetic activity and causes them to flare up with X-rays, making them way brighter than they have any right to be. And last but definitely not least, we have the most extreme members of our lineup, millisecond pulsars. These things are just incredible. They're the crushed leftover cores of massive stars, and they are spinning hundreds of times every single second. As they spin, they shoot out these beams of radiation that sweep across space, just like a cosmic lighthouse. And when that beam hits us, we detect it as a pulse. Now let's zoom in on one specific case that really tied all the evidence together. There was a known millisecond pulsar in M4 with the catchy name PSR B1620-26. This one object became the perfect test case to prove that the whole forensic method was actually working. And this, right here, this is the aha moment. Just look at these coordinates. The radio signal the VLA picked up, the visible light Hubble saw, and the X-rays from Chandra, they all pointed to the exact same tiny spot in the sky. I mean, down to fractions of a degree. This is the cosmic equivalent of finding fingerprints, DNA evidence, and a positive eyewitness ID, all for the same suspect. For this one object, it was case closed. But here's the twist. Solving the mystery of the weird signals actually uncovered a second, much deeper puzzle. And this one wasn't about a few strange stars. It was about why an entire generation of stars seems to have just disappeared. You see, it turns out M4 isn't just one big, happy family of stars. It actually has two distinct populations.
The first group, sp1, has a more basic, primordial chemical recipe. But the second group, sp2, formed later on and is enriched with different elements. Specifically, it's got more sodium and less oxygen. You can kind of think of them as the first settlers of the star city, and then the second generation that was born there.
Okay, now this chart is where things get really weird. This is basically a chemical fingerprint of all the stars. The red and gray dots are younger giant stars, and you can see they're a mix of both populations, right? But look at the blue triangles. Those represent stars in a much later stage of life. They're called asymptotic giant branch stars, or AGB stars, and almost all of them are from that first primordial generation. So, where are all the second-generation AGB stars? This chart just makes the whole problem crystal clear. Look at the first bar. In the red giant phase, which is the first big stage of a star's late life, about 55% of them belong to that second generation. Totally normal. But then look at the very next stage of life, the asymptotic giant branch. The number plummets to 0. 100% of them are gone. They completely vanish before they can make it to this final phase. And this is a huge puzzle. Scientists have seen this kind of AGB failure in other clusters, but those clusters always have other weird things going on, like a strange population of really hot blue stars that was thought to be a key clue. M4 doesn't have that. It looks normal, but it's acting incredibly strange. It completely breaks the pattern, and that suggests there's a fundamental piece of the stellar evolution puzzle that we're just missing.
So, where does that leave us? Well, after all this digging, M4 has actually left us with more questions than answers. It's a cosmic crime scene with a few cases that are still wide open.
We're still trying to figure out exactly how this whole zoo of vampire stars and cosmic lighthouses gets made. We have absolutely no solid explanation for why an entire generation of stars just seems to check out early. And maybe most importantly, M4's weird behavior proves that there's some unknown factor in our models of how stars work that we just haven't figured out yet. And that really leaves us with one final mind-bending thought. Messier 4 is our next-door neighbor. It's the cluster we can study in the absolute most detail. And it's screaming at us about how much we still have to learn. So if this normal cluster, right on our cosmic doorstep, holds puzzles this deep, what other, even stranger secrets are just waiting for us out there in the billions of star clusters scattered across the universe?